Okay, lesson 92 and 97 is going to be finding arithmetic and geometric sequences. So we haven't really talked about sequences before, but before we get started, let's recall back to lesson 22. We went over three different types of functions. In lesson 22, they were discontinuous, continuous, and discrete. So I've got three examples up here. Take your time, try and figure out what some of these are. Pause the video if you need to. The one that's most common that we usually see is our continuous function. That's one continuous, smooth, straight line, could be a curve. I don't know if that's how you spell continuous. So we look here, we've got our upside down parabola. There's no breaks, there's no asymptotes, nothing there. It's just one smooth curve. Next, we had our discontinuous function. Okay, discontinuous functions had some sort of break in it, like a gap. They also could have sharp edges. We've just talked about piecewise functions. Piecewise functions are usually the ones that cause those sharp edges there. And then our last function that we went over was our discrete function. And our discrete function is what we're going to be talking about today. We're going to be talking about sequences, and sequences are a type of discrete function. Remember, we talked about discrete functions. It was any of them that have just a bunch of dots. So they're discrete. You're looking at specific points. So what are sequences? Well, they are functions with a domain of, squiggle brackets, 0. Does not start with 0. They are sequences with a domain, or they have a domain of 1, 2, 3, 4, and so on. Okay, so it's essentially it's your natural numbers. Okay, and the domain is always the same. The domain is always 1, 2, 3, and 4. Domain is always 1, 2, 3, and 4. The range of a sequence is your output after you plug in the domain values into the nth term. So down below here we have a sequence, okay, and you guys can tell this is basically just a function. Instead of f of x, it's a sub n, and that's 1 over n. Okay, now the domain is always starting at 1 and going all the way to infinity. That's all this means, starting at 1 and it goes to infinity. So our domain is going to be 1, 2, 3, 4 on to infinity. So if I wanted to figure out what this sequence is, the range values, I would just plug in my domain values. So I'm going to get 1 over 1, comma, 1 over 2, comma, 1 over 3, comma, 1 over 4. And that pattern would continue on. Okay, so these are my range values there. It's just what I get after I plug in my domain. If you guys were actually answering this question here, 1 over 1, we would want to simplify that and make that just a 1. But these are our outputs after we've plugged in those terms. So what you guys should notice about sequences is their x values, specific numbers, their range values, specific numbers. So it's only going to be points when you're dealing with these. So again, looking at the exact same function, okay, this was what we plugged in. Our domain is always 1, 2, 3, 4. These are our values. So what we get when we're dealing with those, is we get specific points. So if my domain was 1, 2, 3, 4, so on, I'm going to get the point 1, 1, the point 2, 1/2, the point 3, 1/3, the point 4, 1/4, versus functions that we've been dealing with. Okay, this is a function. They're the exact same, just one's a sequence, one's a function. A function is going to have your point 1, 1, and then it's going to have a line that runs through all of them. So the point 2 1/2 is still on it. The point 3 1/3 is still on it. The point 4 1/4 is still on it. The difference between, we've been dealing with functions, Functions are continuous. Sequences are discrete functions. They're just the points. They don't include the lines in between. So arithmetic sequences are a type of sequence. They're a specific type of sequence. And they have the standard form of A plus D, A plus 2 times D, A plus 3 times D. So some examples of some sequences. There's one. We could do okay, so what are sequences here? Well, hopefully you guys can see the rule here. This one is going up 2. This one down here is going up 3. So arithmetic sequences are when you add the same number each time. An arithmetic sequence is going to be any time that you add the same number. Okay? Your A value here, A is always your first term. And then your D value is called the common difference. A value is first term, D value is common difference. So in these cases here, my D value is going to be in 2. In this case down here, my D value is a 3. Let's look at another example. Let's say I've got, is that an example of an arithmetic sequence? Are we adding the same number between each term? Are we adding the same number between each term? Pause the video and decide. Okay. Yes, this is an arithmetic sequence. What we are adding is we are adding a -4. And I am adding a -4. Adding a -4. So when we're doing these, we can subtract to figure out what they are. If you subtract, you are just simply adding a negative. So for this one, our common difference would be a -4. Okay? Now, what we need to know about arithmetic sequences is they do have an nth term formula, which that nth term formula will allow you guys to find any term in this sequence. So, again, first term is A, common difference is our D, and the nth term formula is A sub n equals A plus D times n minus 1. Okay? Again, A is your first term, D is your common difference. Our n is essentially our input value. N is whatever we want it to be. So this is going to be what term we're looking for. Okay? Now, along with arithmetic sequences, there is another type of sequence. The other type of sequence is called a geometric sequence. And a geometric sequence has the standard form of A times R squared, A times R cubed. Okay? Now, some examples of an arithmetic sequence. 1, 3, 9, 27. We could go 2, 8, 32. 32 times 4 be 8.
78.
128. I kind of just gave away what we're doing for our geometric sequences. But for geometric, I'm going to be multiplying by 3. I'm going to be multiplying by 4. So arithmetic is going to be adding. Whoops, I just drew plus sign. Forget that. Arithmetic is going to be adding. Geometric is going to be when you are multiplying. So just like our arithmetic sequence, A is going to be our first term. But then this time, instead of adding a number, we are multiplying by that same number. So what we call that is we call that our common ratio. Okay, common difference means that you're adding between them. Common ratio is going to be that you are multiplying between them. Also, this sequence here is also a geometric sequence. What are we multiplying by? Well, I am multiplying by 1/2 in this case here. Okay, so geometric sequences can also be decreasing. Some of you guys may want to say that this is dividing by 2, and that is correct. However, our common ratio is going to be 1/2. For this one, our common ratio is 3. Our common ratio is 4. So you guys can think of it in your head as dividing by 2, but you need to know that that's actually multiplying by 1/2 to be able to find those. And just like our arithmetic sequence, there is a formula for our nth term. Again, A is still your first term. Your common ratio is going to be represented with an R. Okay, and our nth term formula, A sub n equals A times R to the n minus 1 power. Okay, again, A is just your first term, R is your common ratio, and then our n is which term we're looking for. Okay, so that is our arithmetic and our geometric sequences. On the next video, I'm going to do 4 different examples, and we will work through how to solve each of those different examples.